Welcome to today's explainer. If you work with data warehouses at all, you already know the massive headache of trying to query historical data without ending up writing just pages and pages of convoluted code. It's a nightmare. Well, today, we're going to solve that exact problem. We're demystifying an incredibly powerful data modeling concept, the Type 6 slowly changing dimension.
Okay, let's dive right into this. Here's our roadmap for the explainer. First up, we'll look at the historical data problem, then walk through a real-world HR promotion scenario. After that, we'll introduce the Type 6 SCD, break down its architecture and trade-offs, and finally, wrap up by comparing complex versus simple querying.
All right, let's kick things off with part 1, the historical data problem.
So the fundamental issue we're dealing with here is that operational systems usually just overwrite data, right? They totally discard the history. Data warehouses step in to solve this retention problem using a technique called a slowly changing dimension, or SCD for short. Basically, it's a specialized technique we use to hang on to historical data when attributes, like, say, a customer's address or an employee's job title, change over time. It's literally the bread and butter of historical tracking. Let's look at the traditional menu of standard SCD options we usually have to work with. Type 0 simply retains the very first version, no modifications allowed. Type 1 does the exact opposite. It just overwrites everything with the latest version, completely wiping out the history. Then we have Type 3, which keeps only the immediate previous version, tucked away in a separate column. But as you probably know, the undisputed industry standard is Type 2. Type 2 adds a brand new row for every single change, keeping a full unbroken history. But while it gives us incredible flexibility, it comes with a major cost when it's actually time to pull insights out of that data.
That brings us to Section 2, the HR promotion scenario.
To really see how this builds into a real-world headache, imagine a highly relatable HR scenario. Let's say our goal is to compare the average performance ratings of employees who were promoted specifically from associate software engineer up to senior software engineer. To pull this off, we have our performance ratings sitting in a fact table and the historical employee states sitting over in our employee dimension table. And here is where we hit what we call the Type 2 nightmare. Because Type 2 puts every single state change on a totally separate row, finding an employee's previous history means you have to write these complex inner joins on the exact same table. You're stuck matching the previous row's end date to the current row's start date. Or honestly, even worse, if you want to find their very first designation, you've got to break out heavy window functions like row underscore, partition by the employee name, and order by dates. Analysts end up writing massive, totally convoluted queries for what honestly seems like a super basic business question. So here's the crucial question. How exactly do we get that rich, unbroken history of Type 2, but without all those querying nightmares? It's kind of the ultimate data modeling dilemma that strategic decision makers face when they're trying to build self-serve analytics. Which perfectly sets up Section 3, introducing the Type 6 SCD. Now, this is the absolute hero of today's explainer. But you might be wondering, why the number 6? Is it just the 6th variation someone randomly thought up? Well, no, the number 6 isn't arbitrary at all. It's literally a mathematical hybrid equation. Get this. 1 plus 2 plus 3 equals 6. Let's break down exactly how this works. Type 6 essentially takes the best elements of the traditional types and combines them into one really powerful structure. From Type 1, it borrows the concept of overwriting current values directly, so you always have the latest state right there on every row. From Type 2, it still adds new rows to preserve the full historical records. And then from Type 3, it stores previous or original values right there, in new columns on the exact same row. It's a total hybrid.
All right, moving into Section 4, architecture and trade-offs. Let's look under the hood.
Let's actually look at how this elegant architecture shows up in the database schema. Take a look at John Doe's record here. Notice how the current designation, the previous designation, and the first designation are all neatly packed together into a single row. And this sits right alongside your standard Type 2 tracking dates, like start date, end date, and the isActive flag. Literally everything you need to know about John's entire promotion history is available horizontally all in one place. Let's get to the best part. Section 5, complex versus simple querying. So what happens when we actually try to answer that initial HR question using this new architecture? Honestly, the difference is night and day. On the left side, you're looking at the hallmark of the old Type 2 query, multiple self-joins, window functions to rank rows, just really high overall complexity. But look at the right side, the Type 6 query. Because the current, previous, and first states are all sitting right there in one row, Querying for a promotion simply becomes a basic where clause. You literally just write where previous designation equals associate and current designation equals senior. You do a single direct join to the fact table, and bam, you're done. Extremely low complexity, highly readable. It's beautiful. The massive advantage here is just undeniable. Type 6 radically simplifies your analytical queries for reporting. It completely maintains the comprehensive historical flexibility of Type 2, but it empowers strategic decision makers to actually analyze the data without relying on writing complex SQL. And beyond just our HR example, it's absolutely perfect for tracking specific state changes. Think about monitoring when a customer's risk level changes from low to medium to high, or tracking academic qualifications as a student moves from an undergrad to a master's and then to a doctorate. But of course, in data architecture, there is no free lunch, right? We have to soberly evaluate the limitations and the ETL trade-offs. Implementing Type 6 definitely means increased complexity in your daily ETL process. Your data engineers are going to have to write additional logic to consistently maintain those current, previous, and original values every single time the daily data load runs. Plus, because we're putting the current value on historical rows, it introduces redundant data across those rows. Oh, and a major rule of thumb to keep in mind, you should absolutely not use Type 6 for rapidly changing attributes. It is meant specifically for slowly changing states.
Which really just leaves us with one final question to ponder. Is the upfront cost of that complex ETL logic worth the daily analytical simplicity your reporting teams are going to gain? For a lot of organizations drowning in complex queries and dealing with frustrated analysts, the answer is a resounding yes. It's a fantastic structural shift that solves a massive headache, and honestly, it might just make you rethink the modeling in your own data warehouse. Thanks so much for joining me for this explainer, and keep exploring your data.